Hello, I'm Robert, fact checker and science blogger, and this is to help people who may have heard that that Mercury is going to be thrown out of its orbit or something like that. Now, this is not possible at present. I just showed you in the previous video. You can see how they're all stuck in their orbits. Venus is stuck in its orbit, Mercury is stuck in its orbit. And there's no way that anything is going to happen to that. And the reason is because they're just moving under gravity, and the orbit is decided by the distance from the Sun and the speed and the direction they're travelling, and that's all. And there's no friction there, and nothing can hit them big enough to change direction, so they're stuck in these orbits for billions of years in the future. However, there is a possibility, so there's Jupiter and Mercury. Now, we have, it just as with weather, and they call it chaos, that you can't predict the weather exactly, even several weeks in the future. No matter how good our computers are, you just have a probability, and you can say you've got a 1% chance of rain or something. You can't say with certainty if it's that far in the future. It's the same with the solar system, but not for the orbits. At least for a long time, for billions of years, the orbits are pretty fixed. But you can't tell where the planets are going to be in their orbits if you go tens of millions of years in the future. And eventually you find you can't be sure exactly where Mars is going to be. Its orbit could be there, or could be there, or something. Now, if you go very far into the future, depending on where Mercury is in its orbit in that far future, depending where Jupiter is, there's a possibility of a resonance between Jupiter and Mercury. Very unlikely. Chances are less than a chance in 1,000, much less. But that is the possibility. That is 3.4 billion years from now, far enough in the future, so that you could evolve from some tiny creatures you can only see under a microscope to us half a dozen times, 7, 8 times over, very, very far into the future. So I just want to talk briefly about that. So what it is the eccentricity, and if you look at this, eccentricity means how elliptical it is. So when it's down here it's circular, and when it's here it's a very oval shaped orbit. As you can see, Mercury is the most sensitive. That's not too surprising, because Mercury is the smallest planet, and it's easily swayed by Jupiter and the other planets. Sometimes it gets very eccentric. Now this is just says how elliptical it is. They're nowhere near each other. Venus is nowhere near Earth, but it's more or less the same kind of ellipticalness to it, and they vary slightly. But Mars varies a lot, and Mercury varies a lot. So now we go down and look at this. Then you can see that this is the region that Mercury can travel through, outside that dark band to the inside of that one. This is what Venus can travel through from there to there, and they overlap. And Earth, it's from there to there, and then from Mars it's from there and way out to there. Those are the regions that the planets can occupy as the eccentricity varies. So, for the maximum possible. So you can see there's a possibility that Mercury could interact with Venus. Not now, but sometime in the very far future. Then Mercury could interact with Venus. So then they have these long complex things, simulations, and they work out that it's all very complicated, but they work out this possibility. And here's an example, and there you can see Mercury in the far future. It could have gone like this. It could go like that and become so elliptical that it interacts, and that's Venus, and that's Mercury, and the orbits cross each other. And there's Earth is blue, Earth and Mars can cross each other. And again, Earth and Venus can cross each other. As a result of these changes in Mercury, you can see Mercury there is not going to, and then you've got Venus change its orbit, and the Earth's orbit stayed the same, and then Mars intersects with Earth. So in the very far future, 3.4 billion years from now and onwards from then, this is a very rare, unlikely thing to happen. It's expected that the orbit just stay the same, even 3.4 billion years. But if you explore one tiny little region of the possibilities, then you go right in even more into that, then you find there's a very remote possibility that these things could happen. And then the result of that is, in 1% of the cases, eccentricity changes. but in many cases leads to a collision with Mars, with Venus, Mercury with Venus over the Sun in less than 5 billion years, and no difference to no difference to the orbit of Earth. For one of the orbits, and that's just 1% of a tiny fraction. There are 2,501 simulations within a tiny 2,501 computer simulations. 1% of cases, and in many cases, and out of 201, right, so yes, so there we are. For one of these orbits, increasing the eccentricity of Mercury is followed by increasing the eccentricity of Mars, and a complete internal destabilization of the inner solar system. So I think that would be that one. And that's changed the eccentricity of Mars, and Mars crosses Earth's orbit. And so if you just look at that, and that's just one out of 2,501 different solutions, so it's only one. So 1 in 2,501 is the number that actually did this. And out of the 201 extra cases in the vicinity of that destabilization, 5 ended by ejecting Mars from the solar system. Others led to collisions between the planets, while 1 case led to collision between Mercury and Earth, 29 cases collision between Mars and the Earth, and 18 collision between Venus and the Earth. So, so that is a possibility in the very, 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 very far future. And you're talking about 1 in 200th fraction of a 1 in 2,501 cases. Now, in that very far future, then in any case, they would have to be doing things to cool the Earth with from the sun, because the sun would be warming up by then, and so they would have to cool the Earth up. Indeed, that's getting on for the red giant stage, and the 3.4 billion, a bit before then. Anyway, so the sun would be warming up, and the Earth would definitely would have mirrors, shades in orbit to keep us cool, or we might have moved Earth out a little bit further. And so, if we can move planets and do stuff like that, and we already know how to do that on paper, then we could certainly stop Mercury from doing this, or whichever civilization it is that has evolved in that way, way, way far, far future. We'd be able to do that. And so, I think we don't need to have anything to worry about. If there's anything like us in that far future, then they will have plenty of ways of dealing with the situation. We can already on paper see how to do it. There's several ways you could do it. To move Earth, for instance, or to move Mercury. You could do it by you could set a big asteroid. In the case of Mercury, you could do it between Mercury and Venus, I would imagine, and just set this asteroid to keep on flying past Venus, past Mercury, past Venus, past Mercury. If you do it in the right way, and it does the flybys of Mercury in exactly the right way, you can keep that going up forever. Of course, having keeping in control of it for millions of years, but you're supposing a very stable civilization, then gradually would nudge Mercury back into place again. And so, over millions of years, and there'd be other ways you could do it, quite a few different ways that people have devised on paper that you could do. You could actually move planets if you actually had to in the far future. So I don't think we need to be over anxious about what our descendants are going to do about Mercury 3.4 billion years from now. It probably won't happen at all, but if it does, then that's the problem for them to work out in their time. And it's not really something that we can have fun thinking about it, but it's not really something that there's nothing we can do now that would make any difference to them. Indeed, we can't even, because of the chaos in the solar system, of not being able to predict where the planets are, we can't even know if something we did now would make this more or less likely to happen billions of years in the future. There's simply nothing we can do at this stage. And then 3 billion years in the future, that's then when if this was a very remote possibility, then they would have to try and do something. They would be able to do something about it. Because at even our level of technology, they would be able to do something about it. So hopefully then, so I hope you can understand now, this is not something to be even a fraction of a second of, it's not something that can happen to us now. It's very far future, and it's for them to sort out, and I think we can assume that they'll be able to do it if they have anything like our technology in the far future. And then, in any case, we mightn't be living on planets by then, because we might be living in space settlements. And space settlements slowly evolving for artificial gravity give you absolutely maximum control. And you can choose whatever gravity level you like. You just be able to dial in, I want Earth gravity, I want Mars gravity, I want Moon gravity, I want heavier than Earth gravity. You can basically dial that in, and then by the speed at which your settlements spins, and then in that far future, and then you can have thin film mirrors, so you have whatever climate you like, collect just however much sunlight you want, and the atmosphere exactly as you like it. And so that's really quite likely, I think, that in the far future, billions of years in the future, we may well be living in space settlements, and there's enough space for those. You could make enough of those for 1,000 times the surface area of Earth using just the materials in the asteroid belt. And then you could be right out well beyond Pluto just using sunlight, even without nuclear fusion, which they surely have. So it would be a very different world in the far future.